If you've ever stood over a putt, felt that pressure building, consistency is just, well, it's the holy grail in golf, isn't it? It's that constant chase, that dream. Today, we're doing a deep dive into a really interesting piece of golf tech, one designed specifically to tackle that challenge. We are talking about BGT's new Paradox putter. And this isn't just, another club. It's making a bold claim, basically promising to revolutionize putter design for consistency. Yeah, the source material we've got gives us this incredibly detailed look at the specs and the honestly fascinating, almost counterintuitive design thinking behind it.
Right. And our mission today really is to peel back those layers. We want to look at the intricate physics and the unique design choices that went into this Paradox putter. We're trying to get beyond just the marketing buzzwords and truly understand their innovative approach to achieving what they're calling a zero torque stroke. So by the end of this, you, the listener, should have a real shortcut to understanding this pretty advanced piece of equipment, and crucially, how it might help simplify, one of the most frustrating parts of the game.
Okay, great. Let's get into it then. BGT, Breakthrough Golf Technology, that's a name a lot of golfers will probably recognize. They definitely made a splash with their stability putter shafts a while back. Those were all about improving repeatability and, yeah, you guessed it, consistency. So now they're jumping into the full putter game with the Paradox, and it seems pretty clear that consistency is still like their main focus, their North Star. So the immediate question that pops up is, how? How does the Paradox claim to deliver this consistency, especially with this unusual high-toe heel weighting and this whole zero torque idea?
Well, BGT's core philosophy seems to be about dynamically keeping that putter face square to your stroke path, like all the way through the stroke. And they say they achieve this by aligning the head's weighting with what their engineers actually call the point of rotation in the putting stroke. It's definitely not cheap, though.
Okay.
Both the blade and mallet versions are listed at $700, and they come in the standard 33, 34, and 35-inch lengths.
Okay, $700. So a premium price point. And the goal then is to make it really hard for you to sort of twist the face-off path during the stroke to reduce that hand manipulation that causes misses.
Exactly. Cut down on the need for timing and manipulation.
But let's dig into the how, because this is where the physics gets really interesting. How does this point of rotation actually work?
Right. I mean, the ambition for a zero torque feel isn't unique to Paradox. You see similar goals and designs from, LIV Golf, Odyssey, Everenroll, Bettinardi. Lots of companies, they're all aiming for a simpler, maybe more biomechanically efficient stroke, trying to get you hitting the center of the face more often. But BGT's method is where things get different.
Yeah, this is what grabbed my attention, because usually when I hear zero torque, I think, okay, they've lined up the shaft axis with the putter head's center of gravity. Simple enough. But the Paradox designers seem to be saying, hold on, that's not the whole story. So what is their unique take here?
You absolutely hit on the key difference. BGT's main designer, Scott Burnett, he talks about this concept he calls the point of rotation. Right. And crucially, this point isn't physically on the putter. It's not in the shaft. It's not in the grip. He actually describes it as existing, quote, in the air above the grip and rests between a player's shoulders during the stroke.
Whoa, okay, in the air, between the shoulders. That sounds pretty abstract for a golfer trying to sink a putt.
It is abstract. Think of it like an invisible pivot point, the natural center around which your shoulders and upper body rotate during a smooth putting stroke, almost like an axis running through your chest. And he even gets specific, saying this point is on an axis that's tilted 10 degrees from a vertical line coming straight up from the center of the putter head at address.
Okay, so this external point of rotation between the shoulders.
Yeah.
How does BGT actually, connect the physical putter to this intangible point? Is it just about static balance, or is it something more dynamic?
That's the million-dollar question, right? Because it is abstract. To bridge that gap, Burnett brings in another physics term, the principal axis of inertia.
Uh-oh. Physics term. Sounds complicated.
Yeah, sounds a bit wonky, as they say. But look, think of it simply. Imagine spinning like a perfectly balanced top, or maybe flipping a tennis racket end over end. It wants to spin smoothly around one particular axis, right? It feels stable, requires almost no effort to keep it rotating that way. That stable axis. That's basically its principal axis of inertia. Now, usually this theory applies to things flying freely through the air, free bodies, like a football spiral. But Burnett's idea is that if you align the putter's principal axis of inertia with that point of rotation in your body, then the putter itself becomes inherently stable during the stroke. It naturally wants to rotate smoothly along that path, drastically reducing the effort you need to exert to keep the face square. The putter itself sort of wants to stay on track.
Okay, let me see if I've got this. So it's less about how the putter just sits there statically and more about how it wants to move dynamically when you actually swing it, almost like it has inherent stability and motion.
Exactly. It's designed to resist twisting during the stroke itself. And Scott Burnett actually explained it directly. He said, and I'm quoting here, "This is the first putter where the principal axis of inertia is aligned with the point of rotation in the putting stroke. What that means is it's going to rotate stable you throughout the stroke." He goes on, "Other putters are not like that. What everybody is calling zero torque, that just means the center of gravity itself is lined up with the shaft axis. But none of those types of putters are aligning the principal axis of inertia with the point of rotation during the stroke."
Wow. Okay. That is a fundamentally different approach. He's basically saying other zero-torque putters might be balanced statically, but they don't account for this dynamic rotational stability doing the actual stroke in the same way. That's a huge claim. So how does all this complex physics translate into what the putter actually looks like? Because it has a very distinct asymmetrical shape.
It really does. It's quite noticeable. You've got the heel side being narrow and low, while the toe side is wider and taller. If you look straight at the face, yeah, it almost looks like a triangle lying on its side. But that shape isn't just for looks. It's purely driven by achieving that specific weighting needed for the physics to work. The body itself is CNC milled aluminum, very precise. But the critical part for the inertia is the placement of steel weights. They're positioned in the low part of the toe and the high part of the heel section of the face. And get this, about 2/3, like the vast majority of the putter head's total weight, is concentrated right there in those specific heel and toe zones.
2/3 of the weight packed into those spots.
Yet, despite that asymmetry and concentrated mass, they've carefully ensured the actual center of gravity lines up perfectly with the center shaft position. It's a complex balancing act.
Okay, so the shape enables the physics. And knowing BGT, I assume they didn't just stop at the head design. There has to be more, right? What about the shaft?
You guessed it. It wouldn't really be a BGT putter without their signature tech involved. That brings us to the next piece of the puzzle. These Paradox putters, both the blade and mallet, they don't just have a generic shaft. They come standard with BGT's own stability putter shaft.
Right, the stability shaft. A lot of golfers are familiar with that one already. It's known for making the face angle more repeatable at impact, isn't it?
Absolutely. It has a strong reputation for exactly that, improving the consistency of delivering a square face. And just as a refresher, the stability shaft uses that multi-material construction layers of carbon fiber, an aluminum insert all engineered for extra stiffness and, well, stability, reducing unwanted flex and torque. And one more thing, they also pair it with a mid-size, non-taper grip. The idea there is to further minimize excessive hand or wrist action during the stroke.
Okay, so let's tie this all together. What does this entire package mean for you, the golfer? Standing over that, tricky 4-footer, it sounds like you've got this unique axis alignment, trying to make the putter naturally stable through the stroke. You've got the specific weighting in the heel and toe to help achieve that dynamic stability. Then you add the proven stability shaft for face angle consistency and a non-taper grip to quiet the hands. It really seems like they're combining everything to deliver on that promise. A more consistent, simpler, more efficient putting stroke, hopefully leading to more putts hitting the center of the face. It sounds like they're trying to kind of engineer those little inconsistent wrist movements right out of the stroke for us average players.
That's a perfect summary, I think. That's precisely the goal. So just to recap the core innovation here, the Paradox putter's big differentiator is its unique approach to zero torque. It's not just about static CG alignment. It's about aligning that principal axis of inertia with what BGT identifies as the body's natural point of rotation during the putting stroke. It's definitely a highly engineered solution, tackling a problem that frustrates golfers everywhere.
It really is, and it leaves you thinking, doesn't it? It makes you consider how incredibly complex the physics are behind even seemingly simple actions like a golf putt. Things we just don't normally consider. Does digging into these underlying principles change how you might think about your own putting stroke? Or maybe even how you look at the design of other tools we use every day? You start wondering what other parts of sports or even just daily life could potentially be optimized if we applied this kind of precise biomechanical alignment thinking. Definitely something to mull over.